Okay, so we're just gonna pick up where we left off last time. We're just gonna pick up where we left off last time. Yesterday we ended up with like page 16, example number 2. We're just gonna do the example number 3 together, and then we'll go on from there. Okay. So example number 3, I resetted my calculator already, so that means that everything is completely wiped off. So I'm starting fresh. So the first thing that I'm gonna do, we have to do, is to enter the value, this equation in here. So y1, it's on page 16, negative 2.65 x squared. So you can press the square button right here, right there, or you can press the caret, which is like this key here. So I'll just use that one. Squared. And then I need to get out of the exponent area. Do you hear? Plus 3.9x plus 12. Okay? And press graph. Yeah. Cool. Our class is done.
I know.
Okay. This is applied math now.
Oh,
Yeah.
I just want to talk to you.
Okay. Maybe after at the end of the class. Yeah. Yeah. I'm just. So negative 2.65x squared. How do you square? This square button. You could press on. Well, did you press this? That's your x. You got it. Okay. So yeah, that one, everybody should be very familiar with that one. We've been doing that for the past 2 chapters. Okay. So negative 2.65x squared plus 3.9x plus 12. Now, we know that's a quadratic function, right? Because there's an x squared in there. There's an exponent too. And when we graph it, it looks like that. It's a parabola that's like pointing down. Now, at this particular point, we cannot see the whole parabola, right? So what do you think we should change in here?
The window.
Okay. We're going to change the window so we can see the whole thing. Window. Yeah? Okay, what are we changing? Are we changing the x min, x max, y min, max? Okay, I'm gonna put it back in here. What is it that you can't see?
I guess
mini.
X,
Y mini and X.
Y.
Y mini and X.
Okay, hold on. Are you thinking before you say? What is it that you can't see? The parabola either opens up like that or opens down like that. What is it that you cannot see
The
here?
y-intercept.
We can't see the y-intercept, right? Okay, so what are we going to change? Y max. Y max. So y max, so we're going to change the window. Y max. What do you think we should go to? Right now it's 10. 15, so let's try 15. Okay, let's press graph. Okay, is that enough? Oh yeah, that's enough. That's enough, okay? So we could see the intercepts from here. So how many x-intercepts do you see? 2, right? So x-intercepts is where the line, the x-axis, and the graph meet. So we have one right there and one right there. Okay, we gotta do it individually. So how do we do that? Okay. So how do we do the x-intercept? We wrote this down yesterday, so go ahead and do that.
Why my graph is different?
Oh, what did I? Because you had the old stuff in there. I redid mine, so everything is shut off, right? Okay, and then so the second function. 1, 2, 2, and then retype it.
Thank you.
Minus 1.51. Yeah. 5152.
Okay. So the one of the x-intercept is in the negative area. So x-intercept is negative 1.52. Is that what you got?
Yes.
Yeah. And then the other one would be like something positive. So let's do that. Now, I gotta go to the other side, arrow key to the right, okay, to go to the right side. And I keep entering 3 times. So the other x-intercept is 2.987, 2.99, very, very close to 3. So we have 2 x-intercepts. 2 x-intercepts.
How you do the last one, the second x?
Yeah, so what you need to do, second function trace, intersect, and then I have, earlier it was over here on this side, right? So what I need to do is I need to tell the calculator, I want to calculate that one. Arrow key to the right. Because otherwise it will only calculate, the one that it's closest to. So I want to make sure I'm close to this one. Because this is the one that we want to calculate. Is that good? No? Okay. I'll come back to you. Now let's figure out the y-intercept. Let's figure out the y-intercept. I need to get a little bit fast, okay, on this one. So, so what's the y-intercept? How do you do that? Instructions here. Go ahead and do that, please. So y-intercept is 12. Okay, is that good? Did everybody get 12? Yeah? So, I mean, we should be at this particular point, we'd be very, very familiar with the buttons. We're very familiar with the graphing calculator because we've been spending time with it. Okay, so now we're going to graph this thing. X-intercept is negative 1.52 and then 2.99. So Let's go. This is 0. 1, 2, 3. -1, -2, -3. And on the y-axis, I have to go all the way up to 12. Right? That's because that's our y-intercept, and probably a little bit more. So if I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So negative on the x-axis, one of the x-intercept is -1.52. So -1.52, so right over here. Is that okay? -1.52. And then the other x-intercept is 2.99. So 2.99, that would be like really, really close to 3. Okay, so those are the two x-intercepts. The y-intercept is 12, so it's way up here. And then we're gonna, when we graph this, we can actually see that it goes through the y-intercept, and then it's a little bit higher still, and then it starts to fall down. So it's gonna, just a sketch.
How to do from the -1.50?
Oh, that's this one.
That's 2.91. It was with that. When I did that, I got 2.92. So it was with
Oh,
that.
did you get 2.92?
I didn't do that. 2.987, so 2.9. That's what I got. But I'm asking about the -1.52. Where that come
Oh,
from?
that's this one, the other x-intercept.
So how can we get that?
To intersect again, and then go to the other side. Because I have to let the calculator know which one I'm doing, because there's two of them, right? It's confusing. Okay,
Thank you.
so far so good. So we've roughly sketched the graph of this quadratic function, and then we know that this is just gonna fall down, so we're gonna put the arrow down. Is that okay? That's not so bad. Not so bad. So from here, we can figure out the two. In this case, there are 3 points that are important. We figured out the x-intercepts. There are 2 of them. And then we figured out the y-intercept. There's 1 of them. Okay? Good? So now, we're a little bit familiar with that one. I'm going to look at the characteristics of a quadratic function. Characteristics means what are the things that you can identify. So one of the characteristics that we saw were the x-intercept and y-intercept. We know how to do that now. The next thing that we're going to take a look at is called the vertex. What is a vertex? Okay. So the vertex of a parabola is the point where the direction of the graph turns. Okay? And sometimes it's called the turning point. If you draw a vertical line through the vertex, you will see that the parabola is perfectly symmetrical. So the vertex is where it's turning point. So if you go from left, you know, it keeps going down, 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 down. And then from here, when you hit the vertex, it starts to go up, 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 up again. Okay, this time. So that's where the turning point is. In this case, the vertex is the minimum value, the minimum point it has. Now you look at this one. We're going to go from left to right. So from this side, it's up, 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 up. And then once we hit that vertex, it starts to go down, right? That's our turning point, the vertex. In this case, the vertex is the highest point because there's keeps going down, so that's the highest it can be. So far, so good?
That means it's maximum.
Yes, maximum. We haven't really talked about that, but you'll probably see it there and there. Okay, yeah, right, maximum. Okay, now, what about this one? It's, if you go from left to right, it starts to increase, up, 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 and then hits the vertex, maximum point, and then starts to fall down, okay? Just like when you kick a ball, right? Just like when somebody shoots a basketball. It goes up, reaches its maximum height, and then falls down again. So the vertex is an important point of the graph because this is where either the maximum or the minimum value is. So if we know that the vertex in the direction of the parabola, then we know a lot about the location of the function. We can see the domain of a quadratic function is limitless. We'll talk about that in a second. Like the linear function, but the range of a quadratic function is limited by the location of the vertex. So let's take a look, okay? Because sometimes all these words, so the vertex is where the turning point is. In this case, this is the vertex. The vertex is where the turning point is, and the vertex is the minimum value. So where's the location of the vertex? The location of the vertex is at -2, 0. That's the coordinate, -2, 0. I'll let you write that down, that piece. Domain, okay. The domain, what did we say about the domain before? The domain are all possible x values. Can you think of all possible x values here? Can you have a negative x value? Can we have negative x value? Yes, like we can imagine these ones are a whole bunch of points, and those points have x values, right? Do you see that? And then these points over here, there's lots and lots of them. They have all x values. So your x values could be a negative value, it could be a 0, or it could be a positive. Okay? So, well, we can't list all of the numbers, right? We can't possibly list all of them. So we can say x is the element of real numbers. So x is an element of the real number. So this E kind of looks like this. It's called element. It means a part of any real number that you could think of, any number you could think of. Positive, negative, 0, fractions, decimals, you name it. Those are all in this function. What about the range? What about the range? Range are the possible y values. So you can see your graph is over here. Your graph is not down here. So there's nothing below, nothing on the negative. So if you think about the points, okay, you can see a parabola in here, but really, if you could imagine, those are like billion points plotted together, and then they're like so close together that they look like it's straight, like a line, a curve, not a line, a curve, a smooth curve. You're gonna have y values on a positive, y and a 0, and then do you have a negative y values? No, nothing, right? Every y value would be 0 and over. So our range, the range is 0 to infinity. And why is it infinity? Because if we go, okay, keep going that way. This is going to keep going that way, right? The y values will just keep growing and growing and growing and growing. It's just to the infinity. Okay? Now I want you to take a look at this part here. 0, 0. What about this one? So where's the vertex? This is the vertex. Okay, vertex. And what's the coordinate of the vertex? It's 4, -6. 4, -6. That's the vertex. Okay, imagine this parabola. There's like billions, lots and lots of points. What are the possible x values that you could think of for this one? Could be negative. Can it be a negative number? Yeah, it could be a negative number. Can it be? Oh, you mean this one, -6. -6. So the domain are any x values, element of real numbers. What about the range? The range is from the lowest it can go is -6 and anything above, right? You see this? -6, -6. Okay. So far so good? Yeah? Okay. Now let's see here. Where's the vertex?
In the range, the x should be the first always.
Oh, no, not yet. Yeah, it will change depending on the next one. I should tell you this, and this probably will help you with some stuff with graphing. Okay, this is maybe this, you could put it on the top. Okay, so the parabola can either open up or open down. So how do we know if something is going to open up, and how do we know if something is going to open down? Okay. Yeah, right? So it looks like, oh, this one here smiling at you. This one is like frowning at you, right? It's sad, happy and sad. So how do we know if it's something is opening up? When the lead coefficient is positive, right? So when we see something positive, we smile, right? Right? When you see something positive, you smile. Think about the parabola, it's smiling at you. So what does that mean? Y equals to ax squared plus bx plus c. Which one's the leading coefficient here? A, yeah. So they're saying that if A is positive, it's going to be smiling at you. It's going to open up, right? Now here, it's going to be frowning, opening down. If the lead coefficient is negative, so if it starts with a negative value, x squared, then it's gonna be sad. It's a sad parabola. Okay, so far so good? You could predict now if it opens up or if it opens down, right? If it's going to smile at you or it's going to be sad. Here's the other thing too about that. If it's smiling, where do you think the vertex is? If it's smiling, where do you think the vertex? Vertex is a minimum. Vertex is a minimum. This is the turning point, the vertex. Vertex is a minimum. When it's frowning at you or sad, what's happening to the vertex? Vertex is a maximum. That's the highest right there. This is the vertex. Maximum. Okay. So yeah, you should certainly write that down. So you look at this one. Okay, where's your vertex? It's a sad one. So the vertex is a maximum. The vertex is 0, 10. 0, 10. That's that point right there. What's a domain? The domain are any x values. So x is an element of real numbers. So any numbers that you can think of is a domain. What about the range? You see here, 10, 10. So that means it's from negative infinity up to 10. So negative infinity from lowest to highest. The lowest it can go is negative infinity. We can't, if we keep going, we're going to get into the negative infinity. But our highest is 10. Is that okay? And this one, the vertex is at 2, 2, 5. So domain is from x is an element of real number, and the range is from negative infinity up to the highest, which is 5. So this one here just shows you that one. We're going to try it on our own. Let's see here. On page 18, we're going to try it. What is the vertex here? The vertex is a point, right? It's a point. What's a vertex? It's going to be 5, comma 1. 5, comma 1. Okay. What's the domain? The domain is x is an element of real numbers. And then what's happening to the range? What's happening to the range? Range are the possible y values. So it's going to be
From positive 1 to
From-
the positive 1.
from positive 1 to
The
infinity. Yeah. From positive 1, comma, to infinity. Nobody asked me something about why is this square, why is this rounded. Nobody asked me that yet, but yeah, that's a good question. Like, does it have to be? The answer is yes. Yeah, when there's something is done in mathematics, there's usually a reason behind it, right? So this square bracket tells you that it could reach the 1 in the y value. This round bracket tells you that you could get closer and closer and closer to that, but you cannot really reach that infinity. So the round means could not reach the infinity, right? We could get closer and closer and closer to infinity, but then can't get right to the infinity.
Why we don't put values every element R?
I'm
Why
sorry.
we don't put values like numbers?
Oh, because there's so many. There's so many.
Every element
Yeah,
R?
yeah. You can't possibly list all, because remember, the domain are all x values. Can we think of all? We can't possibly write all x values. So another way of writing that is like all of the numbers that you could think of, that's real number, positive, negative, zero, fraction, decimals, that's part of that. Yeah.
So AC, if we have number, we have to write the
Square bracket, yeah.
If infinity, we have
Yeah, that's a good, yeah. So nice way of Merhowitz summarizing it. It's like if we see a number there, it could equal 2, so it's square bracket. And if infinity, it's round.
Oh, that's this one.
Yeah.
I want to make sure.
Mm-mm.
In line you write x, comma r. Where this
It's
r
not X,
come
it's X element R.
Oh, this is not comma. This is an element of.
like
It looks like this. It looks like a C, but then with a line. That means element of. Means element of. Means part of the real numbers.
always have to be like that.
Yeah, yeah. Always gonna be like that.
Like in the question, almost have to be y element r or x element r.
Y? Or you mean X?
Well, you know, it's
Why is
the
hybrid?
domain, always it's R element R.
Okay, hold on. I'll listen to her first. Let her finish. Yeah.
They were saying it depends the question. Sometimes gonna be x element r or y
Oh,
element r.
no, in this case, no. The Y would give you the no, that one just for the X. That one's just for the X, because X could be any number for the function. Okay. Not gonna be for the Y.
And that's
So which is
So the domain for quadratic functions is always like this.
that's always if it doesn't have a context. You know, context means the application part of it. So
like what we did yesterday or before this.
yeah, so just like what we did yesterday, right? Like we said,
Maybe it's-
well, leave it alone for now, and I don't want you to stress out about it right now. Leave X is a real number, right? It's
R is a
real number. Let's write it down. R means real number. When we get into the context, I mean the application part, then the domain will be restricted. You know, it can't be negative. Okay? But right now, there's no story behind this. It's just a graph, right? Okay, let's take a look at this one. Vertex. What's the vertex for this one? 5, comma 4. 5, comma 4. What's the domain? domain are x. Domain are x values. So x is an element of
R.
real numbers r. Okay. Okay. No, leave it alone for now. Yeah. Don't think much about it for now. Okay.
Relax.
Just relax for now. Well, we'll get to that one. What about the range?
The range is 5.
So what are the possible y values? Imagine all these has like a million billion points. Lots and lots of points. What are the y values for all those points? Negative infinity up to 4. Okay, what are we gonna do? Round bracket for negative infinity and then square bracket 4. Okay, because we cannot touch the negative infinity. It's gonna keep going down and down and down and down. Whereas the 4, we could actually really reach the 4. Okay. Okay. I'm gonna skip this part in here. Okay. We're gonna go to this one, example number 2. So looking at the graph, okay, remember this graph doesn't have a story behind it, it's just a graph. Okay, which direction is it opening? It's opening down. So let's put down. It opens down. Because it opens down, what do you think the sign of the leading coefficient is? Negative. Negative, because remember, sad face, sad, so negative. And behavior. Where's the end going?
Quadrant 3 to quadrant 4.
Quadrant 3 to quadrant 4. Yes.
Only that.
Huh? Why is that? Because this is quadrant 1,
Yeah.
quadrant 2, quadrant 3, quadrant 4. So the ends, these are the ends, so it's in quadrant 3 and quadrant 4. Is that okay? Okay. Just looking at the graph, what do you think the y-intercept is?
6.
6. Yeah, very good. 6. Right there. How do you know it's 6? It's right there. This is the y-axis. And where does your graph and the y-axis meet? At 6. Yes?
Yeah.
Okay. What about the x-intercept? What are the x?
Negative 2 and positive 6.
So negative 2 and positive 6. So negative 2 and positive 6. What is the vertex? The vertex is right here. 2, 2,
Positive 2
8.
and 8.
Yeah, positive 2, comma 8. What is the minimum value? What's the lowest value, y value that you could get? It's going to keep going down, right? It's going to keep going down. So minimum value is negative infinity. Negative infinity. What's the highest value, y value that you could get?
8.
8. What's the domain? What's the domain? X is an element of real numbers. Okay, just say it. Don't just say XER. It's X is an element of real number. The more you say it, it gets.
Okay, range is
What's the range? Okay, the range would be minus infinity to positive 8. So this one here, minimum, maximum. So that's that. Yeah.
So is range talking about what?
Which previous? This one? Down? Down? Oh yeah, we didn't do that one. That one is -4. It's they when the range, the values for range is from lowest to biggest. Yeah. So the lowest here is -4. The highest is the infinity. The highest is
So is the range talking about y? Can't read.
The maximum value here is not maximum.
the max. Oh yeah. Look. We're gonna do that here. Let's try this one first, okay? Yeah. I skipped that one for a reason because that's just talking, right? Not really. Everything is filled out. So let's do this one here. Can you see the difference between the first one and then the second one?
A lot.
The first one here, or example 2, is opening down, and then example 3 is opening up. Okay, let's see. Yeah. Maybe this one will help us. Okay. What's the direction of opening? Okay, very good. Up. What? Because it's opening up, what do you think the sign of the leading coefficient? Positive, right? Positive. What is the end behavior?
Quadratic.
Quadrant 2 to 1. Perfect. Very good. What's the y-intercept?
8.
Okay, yeah, it's a little bit. Yeah, that's 8. What's the x-intercept?
X-intercept is 4.
4.
Yeah.
How many x-intercepts do we have?
1.
Just one. Just one, right? You have this. This is the only x-intercept we have. What's the vertex?
4.
4, 0, yes. What's the minimum value? That means the lowest y value. The lowest is 0. What's the maximum? Infinity. Infinity. Okay. Now these two, that will help us with the range. So let's go ahead and do that one right now. What's the range? From 0 to infinity. Square brackets at 0. Round bracket for infinity. So the minimum y value is 0. Maximum is infinity. What's the domain? This will be the easy one. X, an element of real numbers.
Do you not change as well? Do you not change as well?
No, not in this kind. Not in this kind of question. But when we get to the problem-solving one, it will change. Okay. Did that help a little bit now? Sorry, Alyssa? So I wasn't sure which one you're asked. From here? No? Okay, well, we'll keep going. Okay, now this one doesn't have a graph. Oh, we're going really slow in this one. Okay. This one, no graph. Oh, but before we type it in, what do you think the direction of the opening is? How do you know?
Leading coefficient.
Yeah. Yeah, because the leading coefficient is positive. It's up. Okay? Sign of leading coefficient is positive. Okay, so let's go ahead and type this function in. I'll do the same thing. Go. So we expected it to be going up, yes?
Yeah.
Yeah, okay, good. Okay. Did everybody get this kind of shape?
Yes.
No? Oh no.
Right arrow key, because right now you're still on the exponent area. Squares, you can type this in, or you can type this in. The exponent 2, or you can just press this. And then you have to get out of the exponent, so you go arrow key to the right.
Okay, good. What's the end behavior? Quadrant 2 to quadrant 1. Okay. What are the x-intercepts? Are there any x-intercepts? Nope. So let's put none. Yeah, we can't put 0, right? Because if we put 0, that means the x-intercept is at 0. So just put none. What is the y-intercept? Oh, let's figure that out. How do we figure out the y-intercept again? Second function, trace. We're going to do the y-intercept. 1. 1. And x is equals to 0. So the y-intercept is 7. Okay. Now, how do we figure out the vertex from here? Where is the vertex? So the vertex is this point here, the lowest point, the minimum point. So how do we do that? So here's what we're gonna do. I'll write it down over here to determine. Oh yeah, you can't see that one, right? To determine the vertex. How do we do that? On a calculator. You're gonna go second function. You're gonna go to trace. Second function, trace. Now, you're gonna pick either 3 for minimum, or you're gonna pick or 4 for maximum. Okay, so we're gonna either pick 3 if it's a minimum or 4 if it's a maximum. After that, we're gonna use arrow key left and the right to set boundaries. And then you're going to press enter each time we set the boundary. Okay. So let's write that down first, and then we'll just finish that thing off. Okay, so if we take a look at this one here, we know it opens up. So the vertex is a minimum. So we go second function, trace. Second function, trace. Is everybody here with at this stage? We're gonna go to a minimum, so 3. Press 3 for minimum. And then this is where I was talking about determining the boundaries. We're gonna press the left and right boundaries. So if this is, just watch it for now, don't do it yet. If this is my vertex, I'm gonna try to mark it. So if that's my vertex, I want to make sure that my blinking cursor, right, this blinking thing is on the left side of it. Okay, so I'm on my left side, so that's okay. So press enter. So it says here, am I gonna go to my left? Yeah, I have to make sure I'm on the left. So press enter. And then it says here, let's go to the right boundary. So I'm gonna go press the right arrow key, go to the right of the vertex. Okay, right arrow key to the right, and then press enter again. Okay, so why don't you do that part? So do the left boundary, enter, right boundary, enter. Just once. Like you're gonna do left boundary, enter once, and then go to the right, enter, and then it's gonna say guess. You're gonna press enter again. So what does that say? Our vertex is at 2, 5. Our vertex is at 2, 5. Yeah, that's okay. That's pretty much 2, right?
Rounding.
Yeah, if you round it off, 2, 5. Okay, so from here, what's our minimum value? What's the lowest y value that you could think of or you could get? Our lowest is 2. Lowest is 5. Lowest is 5. What's the highest value that we could find? Okay, infinity, right? Because it keeps going up. Infinity. So what's the range? The range is from 5 to infinity. Round. Square. And then the domain is x is an element of real numbers. Okay.
I don't know how did you found that is x intercept is
Again.
the nonce.
Oh, this part, x-intercept. Okay, that's a question. That's okay. This is your graph, right? And then this is the x-axis. So here, in this case, that this graph and the x-axis don't meet at all. So there is no x-intercept.
In
So
that
there's
case
none.
is
In that case, it's none.
so if you do return back a little bit, do return back a little bit.
Turn it back.
Yeah.
Which
page,
one?
Page 18.
Okay.
This example now.
This one here.
Yeah. So the sets minimum The maximum value is none also.
Oh, you mean here?
Yeah.
The maximum, that should be infinity. Yeah, is that what you're asking about, Danan?